Can y'all hear me?
I was muted. Okay, that's my fault. Now it should be working. Let's check that out and see. It was completely muted before. Yeah. Hello, hello. Is it is it working? Should be. Should be. What do you think? Say something. I'm saying something. Okay. All right. So we'll get on to the news here, monthly space news, focusing mainly on the Starship and actually what the Chinese are doing, a combination of those two things. So, no, this isn't working. Hmm? Yeah. In fact, I can talk about that. I think the problem is whenever you click on Zoom, you no longer have PowerPoint. Oh, just refocus. Yeah. Oh, well, that should have done it. Okay. So anyway, you probably heard Elon Musk talking about going to Mars. In fact, he calls it the gateway to Mars. That may be a slight dig at the lunar gateway that the NASA's doing, but fundamentally, he's just saying we need to go to Mars, and here's a ship that'll help get us there. So that is Starship, and they just completed test number 3, flight test number 3. It was launched on March 14th. Basically, it was nominal in most ways. Nominal meaning good, meaning it worked as expected. What? Oh, yeah, definitely sign up for the drawing. Okay, so it made it to near orbit, which was the plan. But even more basically, it didn't damage the launch pad. So now they're well past that problem that they had on test number 1. All the engines fired and completed their full duration burn, which they had before. The hot staging worked, meaning they start the second stage before they release from the first stage. So that was risky for such a big rocket, but they've now demonstrated that works twice. They got up to orbital speed and altitude, which is really what the goal was. And it looked like the thermal tiles held together, so they stuck to the ship much more than they happened in the earlier test. And one way to look at this, still the way it gets reported in the news is spaceships blew up. But, when you get down to it, where were they even blowing up? It's typically after they did what they were supposed to do. All of this is related to, recovering and reusing, in this case, both the first and second stage. Right now, you could say this rocket has already demonstrated it can move a large quantity up to orbit, get there pretty quickly. So everything is related to really reuse. And that's something that people lose sight of. They say it's blowing up. Well, yeah, but other rockets don't even try to do what they're doing here. So it's kind of a different thing. No, not with 2 stages anyway. So you have that. So here's an example along the way of the hot stage separation. Now, this is actually, I've got a bunch of videos or a bunch of slides copying the video, as the launch video showed. And the way you read this, like on the far lower left corner there, they're showing you which booster engines are burning. So in this case, there were just 3 in the center. Those are the ones that are gimbaled, meaning they can angle so they can make corrections, angle the thing a little bit differently. The ones around the outside ring are just fixed. They just go straight down. And the ones in the middle, I think, are gimbaled too. The one on the right that's the second stage, and they had just started up the second stage engines, actually all 6 of them, and I think the display was probably in the process of just changing over. Because normally when the engines are off, they just show those little hollow circles like you see on the far left side. So here you're looking down from the first stage, you're seeing, from the second stage, I'm sorry, you're seeing the firing going on, you're seeing the control fins there, those are still associated with the second stage. And then down below it, there's the first stage, which still has some engines going. So that's what you're looking at. So they got some new milestones, as they went past the previous test. First of all, they managed to do the complete flip. The ship goes up, the stages separate. Basically, that first stage has to flip over and head back, and it tries to head back toward where it was launched from. And it blew up last time during that point. So they now have gotten past that. And they did the full burn, meaning they slowed down as much as they needed to go into a coast phase, and then they were coasting down. And actually, they coasted back pretty successfully within about 6 kilometers of the final ocean. But they did lose control. It was kind of a rolling oscillation. It was actually, it would be called roll if you're thinking of how planes or ships are rotated. It rotates left to right, indicating a control problem.
Show us you can show us the model over there.
Oh, here we go. Yeah, okay. So here we have a model that somebody is going to win. And anyway, so it was going like this. Now, anybody who's ever worked in controls indicates, okay, you got a problem here. Now, it might be that it's badly tuned, the control. More likely, something probably wasn't working quite the way it should, or the model that they used to build it wasn't working quite the way it should. And these are all things that are, kind of new to starships. So, it's not the kind of thing they can test out so easily. This is how they find out if their models aren't good enough, fundamentally. You can't get good control if you can't really get a good model in your system. So what happened, though, they were losing control, and also they probably had an engine failure on restart. Maybe by now they've sorted that out. The last time I looked, they hadn't really definitively said that, but it sure looked like it. Apparently, when you looked at that display in the lower left corner, they were showing a couple engines firing here and there. It was very erratic. So anyway, finally it blew up. Actually, at only 460 meters, so that's pretty close to the ocean where it was supposed to fall. So that was the booster. But in any case, they'd made it a lot further than they had before. Yeah. So the goal is, long term, the goal is for it to come back and land either on a platform in the ocean or actually back at the original, launch site. And they're getting, closer. The first step was they were just hoping to land it kind of vertically, and drop down into the ocean. They didn't quite get that.
They want to bring it in sort of belly,
So the thing goes down. Yeah. And actually, one thing that happened on both the first and the second stages was they did have these rolling kind of problems, which meant that the thermal tiles, which are supposed to take care of the heat, it's supposed to come down kind of like this. It's kind of coming in kind of slowly. And the problem is when it rotates, you're getting a lot more heat on the lower side. Well, if the upper side is exposed, and that nonetheless, it didn't appear to have melted anything. But it's something they have to worry about.
It nose down rather badly at one point.
Yeah.
Doing a belly flop, doing a nose down entry.
Yeah, and these things are rotating. And actually, it's even more obvious in the second stage, which I'll show you in a minute here. So now we're going to look at the upper stage. Now, first of all, normally the thing goes up, so it completed its engine burn to get as high as it was going to go, and then it's just supposed to kind of coast along for a while, heading along, up in the, where there's essentially no atmosphere to speak of. And that's further than they ever got before, because the last time it blew up at that point. So first of all, they were doing a test. There were 3 tests they wanted to do. One was transferring fuel, and they were just doing it between a couple of tanks. There's a little tank way in the very front of the ship, and there's one in the back. Well, there's a big one in the middle. And they were just transferring fuel. They need to show they can do that in zero gravity conditions, because they need that, well, actually, to go to Mars, even to go to the moon. Fundamentally, you need to get a bunch of fuel up there, like a fuel depot, which will just be another one of these, and transfer fuel to it multiple times to basically gas up so they can then go to wherever they're going, the moon or in the future Mars. So they were testing that out. The result was they said it worked, but of course we can't really tell, and they didn't really have final results on that. They were also going to test the payload door opening, specifically for the style of launching satellites that they want to do for their own Starlink. And I've got a slide on that later. And also just testing out the control. I've got a slide on that later too. They also, at this point, established the first hypersonic reentry. Now, once you've gotten up there, and as you start to come down, you're going about 20, you're going at orbital velocity, which is at that altitude is like 17,000 miles an hour, 25 times the speed of sound. That's hypersonic reentry. They hadn't actually done that before. So this is the first, and that's why they have those tiles. Now, as I said, it turned out they had a rolling problem, and so the thing was upside down even at times, and as a result, that definitely hurt it. So they found out that they need to improve their controls. But basically, they're testing the heating. Are the tiles good enough? They're testing the control systems and just the aerodynamics in general to make sure they understand how the vehicle is actually going to work. Because you really can't test it that well on a ship this big. You can't just throw in the wind tunnel. You don't have a wind tunnel that big, especially a supersonic one. So, and just to point out on this display, like the lower right corner here, you see, indeed, the engines are off. That's what it looks like when they're just coasting, if you ever want to watch one of these. And they show the orientation. If you're looking along the bottom there, there's a little place they're showing the thing is, slightly angled up. It's pitched slightly up. and which is how it was supposed to be at that point. I just want to show these things because these things change as we look. Now, one thing you'll notice in this picture, they're showing that the Earth looks kind of vertical to it here. That's because the thing is rotating. And every one of these, if you looked over time, every time you looked at it, the Earth was in a different position. And because it was rolling, they lost control, which ultimately, would lead to its demise. As far as the in-orbit fuel transfer test, shows a diagram of an earlier version, actually, of Starship. Every one of these ships they have what are called fuel header tanks. It's a small tank. They keep those so that they can guarantee that there's no vapor anywhere. They keep them under high pressure in the front end so that when they want to restart an engine, for instance, even in zero gravity, they don't have to worry about it just having a bunch of gas and liquid kind of floating around aimlessly and the engine's not working properly. So that's called a header tank. And that's a typical kind of thing they have. The test they were doing was just moving some stuff from the header tank over to the main fuel engine, or the main fuel tank, which is there kind of in the middle of the thing. So again, we have to take their word for it that they did that, but presumably they did. They had an interest in that working. They moved about 10 tons of liquid oxygen, or at least that was the plan. The results haven't really been published yet.
We have shared the information with NASA. NASA seems to be happy.
Yeah,
They're going over the information.
Yeah, NASA's quite concerned because NASA needs this to work. So in the future, in general, this is sort of the conjugating paramecium kind of a picture. I don't know how thick those pipes are supposed to be, but somewhere in there, there'd be pipes so that you're going to be passing fuel from one ship that came up laden with fuel, fueling up the other one. So that's what they expect to be doing in the future. And as I said, that is important to NASA, specifically Artemis 3, which is the very next moon launch. That's the one that will actually take a crew and take it around the moon. Now, to do that, or to land even. So if you're going to do that, though, it takes multiple loads of fuel for one of these starships going up, multiple loads of that as the payload to go up. So what they do is they start off with an initial launch, which should be the one on the left over here. It goes up, and then several launches are done to go up and fill, and then they return. So that whole cycle is not quite shown on here, but there'd be multiple launches and returns to Earth and everything. At some point, then they launch the SLS that actually is carrying the human crew. They take it up and they meet up in orbit, and they transfer the crew to the human landing system, which is a Starship, one of these, except it doesn't have fins because they don't do any good around the moon. They're never gonna see an atmosphere, so they don't have fins and a few other things associated with atmosphere. So anyway, they would then go and they'll land, and then when they're done with their mission, then they'll take back off, and they come back, and the crew returns to Earth. So that's the whole thing. But all of this depends on refueling in orbit. So this matters to NASA. It matters to SpaceX and for all future missions, including Mars. So I mentioned hi, yeah, come on in. So I mentioned the testing of the payload doors. They're calling it a Pez dispenser for people who are younger. That was a kind of a candy. I don't know if they still even have them, but they were sort of like chalk, but they were in a tube like this, and you could shoot out a little pellet, one at a time, kind of a chalky kind of a candy. Well, anyway, that's what they're doing is they're going to send out the satellites kind of in little flat packs, one at a time, shooting out the door. And the door, you can see it here at launch. It was closed. It's this little thing right in the center of the picture. That's sort of the initial outside view. This was right during the takeoff. Well, you can see 4 seconds into the launch. All the boosters, rockets, engines firing. That's what it looked like. This is what it looked like inside. And so what they did is, once they were up, the second stage is just floating in space, then they had pistons, which are shown here, which open a door. Now, it's a little hard to tell if you look at the picture by itself, but look at the bottom center of this picture. There's some little traces of gas there. They're just kind of open to space at that point. There's still some moisture or whatever kind of wafting its way out. And if you look at the next one, down there at the bottom, see that blue? Oh, sorry. It looks kind of bluish, but that's the door closing. So they started off with it completely closed. They didn't show that, but then they showed the door open, and there was a lot. In some of the earlier parts of the launch, you could see more and more of that vapor there. And then if you watch again, that door was closing. Now, it wasn't actually clear that the door ever got fully open or the door got fully closed. You couldn't really tell that. I mean, I'm sure they know, but we couldn't really tell by looking at it. So some people have raised questions about that. But anyway, at least they've started now. They've done some testing, at least on opening and closing the doors, which will be a necessary part of deploying satellites.
In the live video, that door looked awful.
It was,
Up there at the end.
yeah.
It was, as they were moving it around, it kind of was all over the place.
Yeah, it wasn't completely convincing, but at least, you know, it's a start. So they're doing that. Note again that the thing is, the craft is completely, for the pitch here is essentially zero. It's just going along, kind of coasting. Now the next one, you'll notice here it's pointing up. They've lost control at that point. It should not be pointing up. So that's the pitch is wrong. And as mentioned, so there's two problems. The pitch, meaning it's now pointing up instead of going sideways like it was supposed to be doing. And the other thing has just been rolling. So there's at least two axes of rotation that are screwed up. So that, you know, they've lost control. But it doesn't hurt it right away. Now, and in fact, as I said, it's pointing up. You'll notice also, if you look down, those white things in the bottom, those are the clouds. So you're looking down directly at the surface of the Earth, which you weren't in some of the earlier pictures. Remember looking back, one of the earlier second stage was there, it was kind of, you know, it looked kind of horizontal. So clearly there's a lot of rotation going on here that is not really desired. So they have to work on that. Anyway, now the other interesting thing is that when you're going that fast, you get plasma. What happens is you're hitting the few particles of air that are there, you're hitting them so hard, they essentially dissociate into ions. It's called plasma. And that looks like it might be some kind of engine. Now, all that red kind of look there, that's not. That's just plasma. And so you're seeing that. And that was interesting because that was also something new. Normally, when you got like a rocket coming down, you're trying to communicate with the ground. Well, all that plasma is forming in the front, the front and immediate sides of the vehicle. You can't transmit a signal to show a picture of that. But here, they're transmitting to satellites that are above it. So they could. So they actually were able to show this. That was something new. Nobody had actually seen any of these rocket engines and the plasma that gets generated. No one had ever seen that during that descent phase. This was actually during the descent. And here's yet just another scene here. Again, that sure looks like it might be rocket engines. Nope, that's just plasma. And that was one of the more dramatic ones that were there. So they did have problems. It all comes down to control. They couldn't control the attitude, meaning the orientation, pitch horizontally, vertically, or the rolling. And of course, once again, the thermal tiles then are not doing their job because they're not in the right place all the time. So they had a problem. They did skip one test, which was an engine restart. You want to make sure that you can start your engine in space. They hadn't actually done that yet. But because they'd already lost control, they didn't want to make things worse, so they didn't do that. And then the ship, finally was just lost during reentry. And in terms of orientation here, this is a case where here the ship was pointing down. It's just clearly lost control. Okay, next topic, the Chinese lunar exploration program. You were asking about this symbol. Actually, the symbol is meant to vaguely suggest the Chinese character for moon, which is, in fact, among those four characters below it, that's actually that one right there. That means moon. And so they take a lot of liberty, but that's kind of common. The Japanese do the same thing. They make big adjustments and, sort of in the imagination. But the other part of this is symbolic is those are supposed to be human footprints, kind of indicating human footprints on the moon. Now, of course, they can't really be real footprints. Your feet would be destroyed instantly from the cold. So maybe they didn't think that through, or maybe that's why they're so fat. Maybe they're in boots, kind of hard. Which reminds you of the old, if anybody saw the old Space Force show where they were talking about, landing on the moon, and the general says, "We want to see American boots on the ground with American feet in them." Well, they want to see Chinese feet in them. By the way, the first two characters are basically in China. It's middle, first character is middle, and the second one is country. They always thought of themselves as the center of the world, and that's kept up ever since then. Okay, so early launches. Going back to 2007, they've been doing this for a while. Now, so far, they've all been robotic, and of course, that's going to change in the future. They have a whole program series named after the moon goddess, Chang'e, and basically, they've just been improving the capabilities over time, and also doing a lot of other exploration. Like after they dropped off an orbiter around the moon, they just, while they're at it, they had some extra fuel. They decided to go over to the midpoint between the Earth and the Sun. Well, L2 was actually on the outside, but they just moved around. They went and they did an asteroid flyby, and then they just went on to deep space. So they're getting good use out of these craft. They finally did land. 2013, they had a lander and a rover, and that was on the near side of the moon, being the part that you can always see, northern hemisphere. And then they had a test really for future landings where they wanted to make sure that they could actually return samples to Earth. So they didn't actually go down and land and take a sample, but they did everything else. They sent the capsule back. They made sure that they could get it back to Earth and recover it. So they tested all that out. And then they put up a communications relay. They needed that because they wanted to land on the far side of the moon. So if you're on the far side, you can't have a radio signal going directly back to Earth. So they thought about that. They figured out what to do about it. And here's what they came up with. Actually, the idea of the halo orbit, there's actually a lot of early American literature about that. It's not a new idea. They were actually the first to do one, though. That was one thing that's different. Let's start on the right-hand side of this diagram here. So you got the Earth where the monitoring stations are. You got the moon, which is rotating around the Earth in the plane of this picture. So think of that as being like there's a circle. The moon is going in a circle around that, flat on that screen. So the near side always points to the Earth. The far side never points to the Earth because the moon rotates just exactly at the right speed to make that happen. Now, there's a point called the Lagrange L2 point, which is out here on the far right-hand side, where basically you can have an object like a satellite moving at the same speed as Earth, the rotational speed. So it kind of looks like the left-hand side here, where say you got the Earth in the center, you got the moon in that circular orbit there. And then in between, you draw a line between the Earth and the moon here. And there's Lagrange point 1 and 2. One is where there's exact gravitational balance between Earth and the moon. And it's easy to see that one because you can imagine if you just got a little closer to the sun, well, the sun's gravity would start to win out and it would pull it away. And, or vice versa going to the moon. But you have a similar kind of thing going on where normally you expect if you're farther away from Earth, you'd expect the orbital speed to be slower in angular velocity in particular. But it's not. And the reason is you have the extra pull of the sun, and that's maximized right along the line between the sun, or the Earth and the moon. So that's why it's pulling it along. So that L2 point, that's quite strategic because you can't transmit anything there. The Earth is always in the way. However, if you have one going in a circle around it, so that's what we're back to the picture on the right-hand side here. They put the satellite in an orbit around the L2 point. And the reason you do that, now this is an orbit, think of that as perpendicular to that screen. So you're far enough out, as long as you're up high enough, you always have a view of the Earth. And that's what's shown in these green lines here. No matter where you are, that satellite can always communicate with Earth. And that's why you put it out that far. Now, you can't necessarily communicate with everybody on the far side because at some point, the curvature of the moon gets in the way. But, you can cover most of the moon anyway. So they can plan all that out. So that's what they did. And actually, the Lunar Gateway is going to be in one of these kinds of an orbit as well. So anyway.
Satellite orbiting around.
It doesn't really get pulled, but it takes minimal fuel to do it.
I can sort of explain that.
Okay, yeah, go for it.
Basically, it's like a bowl. It's a region of space out here that's shaped like a bowl. Okay, and it's got curvature. Yeah, it's got curvature. It's like a bowl. And so if the perfect spot is right in the center of the bowl, if you go in any direction, like that way, you're going sort of uphill along the edge of the bowl. And so if something knocks it that way, it'll tend to want to come back towards the center. If it goes this way, it'll get knocked this way, it'll tend to want to come back towards the center of the bowl. It's curved.
Yeah, it's not quite that simple, though, because that's true for the L4 and the L5 points. They're actually, from a control standpoint, they're actually stable. Meaning exactly as you described. If something gets off of it a little bit, it'll get pulled back in. And that's why they have all those asteroids collected that what are called the Trojan points around Jupiter, which some of the spacecraft have been to, where you go out there and there's just a whole pile of asteroids like kind of all accumulated there. They just collected it. And there's two of those, there's L4 and L5. It's more complicated here because it's called neutral stability, meaning you can drift off. The problem is it won't necessarily get attracted, but it still takes very little energy to do it. So, the basic idea is, you're imagining there's this, imagining you're plotting above a two-dimensional surface. You're plotting the force of gravity, but it's a little bit more complicated.
You've seen the pictures where they say, imagine like the Earth is sitting on a rubber sheet, and you can see the end, the rubber sheet, and it's got the grid. This is what happens. Mass causes space to kind of get thin right there. Well, that's what's happening here. Only the well is more like a shallow bowl. That's really true, like you said, at L4 and L5. It's not quite, it's more like a dimple. Less of a bowl, more like a dimple. But you are pretty good with your navigation. You can stay very close to that dimple and you use very little fuel to stay there.
Yeah. So anyway, the big advantage of that orbit is that, as I said, is never blocked from Earth. So and you can cover most of the far side of the moon with doing that. Okay, so Chang'e 4, that one actually had a lander and a rover. That was the first one that did that, and that was in the South Pole region on the far side. So they had a lander and a rover. They didn't have sample return as part of this project. Or maybe they did. No, they didn't have it on this one. But anyway, it looks kind of like that. There's the lander on the left side. The rover rolls off. Oh, go ahead. Rolls off and goes and does the explorations. Now, as far as the landing site, this is a picture of the moon on the left-hand side. This whole area where they landed is called the SPA. That's the South Aitken, South whatever it is, Aitken Basin. There's a bunch of individual craters inside that, shown in more detail on the right-hand side. But the point is, you're not actually at the poles. But everybody's kind of interested in the poles just because there's a whole variety of reasons for that, like availability of water. So everybody's focusing on that. And even back then, they were trying to get relatively close. So Chang'e 5, now it is an orbiter and a lander. And this is the ascent vehicle, so it looks a little bit different because they took samples. They didn't have a rover in this case. They just took samples directly from the thing. I think it could go down like 6 feet or something. Drilled a bunch of samples fairly quickly and then returned. And so this is a fairly elaborate operation because you got to go up, you meet back up with the orbiter. The orbiter then heads back to Earth, and then it drops off a sample capsule. It's pretty much actually a lot like the Apollo missions went. It was a similar kind of an architecture. But anyway, them doing that. The point is, it's a fairly elaborate kind of thing. They did it. They managed to take samples back from the moon. I would add, by the way, the United States never did that. We did it with people, but we didn't, which is a whole lot harder in some ways because of all the life support issues. But actually, to do it in an automated fashion like that, that's actually pretty impressive. That hasn't really been done much. Okay. The satellite then they were using before, I talked about, had it being in a halo orbit. Well, they rethought that after their experience. The problem is it still takes fuel to maintain that orbit. So the new one, which is Choi-Chao 2, is bigger. It's more powerful, but they have the same issue. They want to get communications with the far side of the moon. They just have a bigger one. The antenna is the same size, but everything is more powerful otherwise. Everything's bigger and all that. And they also sent up a couple of smaller test satellites. Long term, what they want to do is they want to have a network of communication satellites so they can communicate with their rovers and their landers and everything on the near and the far side of the moon. So they're setting all that up. So its orbit is different, though. They just went for a very highly elliptical orbit. And this is not to scale. If that were to scale, it wouldn't fit on the screen. Because it's like a 200 by 16,000 kilometer orbit, like a 1 to 800. So that meaning, if you were 1 foot wide, it'd be 800 feet long, and it doesn't fit. So they had to, take some liberties in this picture. And initially, or it ends up with a 24-hour period. I think it starts off with 12. But anyway, the point of an elliptical orbit is that basically you spend most of your time, you're going very, very slowly when you're farthest from the moon as it goes around. When you come in, you start going really fast. And you can kind of think of that as a trade-off in kinetic versus potential energy if you've had some physics. That basically, you go up high, you don't have as much kinetic energy. What was that? Okay, not mine. So anyway, so that's desirable because and this is shown kind of emphasizing the fact that the long, slow trail, although you're far from the moon, at least you have visibility. And you don't have that much of a problem. There's no atmosphere in the way, so the distance isn't so much of a problem. The main thing is just being able to loiter there. So you're going kind of slowly. So that's what they're going to do. And the reason they like that is not only is it elliptical, this is what's called a frozen orbit. And that matters, especially in the moon. Frozen means it's stable. And normally what happens on Earth, it's not so much of a problem, but on the moon, it's a big problem. You have big variations in the density from place to place. They call it mass cons or mass concentrations. And they found actually that low lunar orbits basically are almost always going to end up crashing. They get disturbed so much just from going over these really concentrated masses. But they found a few that are actually, they're frozen, that will last essentially, maybe not forever, but for a really, really long time. That basically that any perturbation is kind of canceled out. You get pulled one way, well, then you get pulled the other way, some other part of the moon. There are 4 known circular lunar frozen orbits. They found that out back in about 2006, and just partially by experiments, and then I guess partially by math, as they got a better feel for the topography and the gravity. They've been having orbiters. China and the United States has had orbiters, and India has had orbiters around the moon for a long time, and they've been measuring a lot of this stuff. Like, what is the local gravity? It's not really fixed. You think about that. Earth is less of a problem because you have tectonic plates, you got volcano, everything, and you got biology and wind, water, everything kind of tends to relocate the mass quite a bit. And you don't have any of that going on the moon, and that's why you have much worse problems navigating there. So anyway, there's frozen ones, but that's for circular. For elliptical orbits, somebody else did a study about the same time, figuring out where some of those would be, and they picked one of those, where they think basically they're going to minimize propellant use. They hope not to do any orbit corrections for the next 10 years. Unlike the Chuichao 1, the first one, is in the halo orbit, which is kind of unstable. They need to use 80 grams of fuel for a correction every 90 days. Now, 80 grams may not sound like that much, but over a period of years, they run out because these things aren't that big. So they decided to go for that. So what's coming up? Well, they're going to have a lander with an ascent vehicles and sample return. This is far side. So they're doing sampling from the far side and returning. So they're kind of putting it all together at this point. They're pretty big. It's about 7,000 pounds on the lander. 1,500 pounds of that is the ascender. And what's interesting is the science payloads, they're not really all just from China. They have France, Italy, Sweden, and Pakistan all contributing instrumentation or various parts to this thing. All of these return about 2 kilograms of samples, 4 pounds. From the surface and from up to 2 meters below the surface. So that's coming up. That's coming up in May. They had just launched that the communications satellite. That's in place. That's working now. And now they're going to do the lander in May. What's coming up beyond that is putting more of it together. This time they're going to have a flying probe or a hopper. Where basically not only will they be taking samples and having rovers and things, but then they'll actually jump around from place to place, and they can jump down into a crater, for instance, places you couldn't really drive. So they're trying to expand what they're going to be able to do, and return the samples as well. And then they're going to get a lot more serious about, okay, what do you really need to do to establish a base on the moon? They're going to do a lot more lunar science kind of stuff. They're going to do a lot more surveying to figure out what the materials are. They're going to try 3D printing of a structure, that's a real deficiency of the US programs. We're not really thinking about actually living on the moon so much. We're just thinking mainly about going there for a short period and coming back. They're making much more of an effort to figure out what do they really need to do to establish a true permanent base on the moon. And their goal is 2029, 2030, somewhere in that region, actually put people up there. So that's the start of that. Quite aggressive. They've moved that up quite a bit. It used to be like 2035, and I think they moved it up. Certain amount of competition there in the US. Now, the moon base. ILRS stands for International Lunar Research Station. It is an international effort, but clearly this is definitely Chinese run. I mean, there's not any question about that. I mean, even Russia is kind of a minor partner in the whole thing. And it's mostly countries that don't like us very much when you get down to it. So there's really, there's 2 groups in the space race. There's just 2, and this is one of them, and then the American-led one is the other one. And what's interesting is you have some people that are also sort of U.S. allies involved. The United Arab Emirates originally signed up for this, but then, and they were going to actually remember, they had a rover in one of these earlier lunar missions that was supposed to, land and go out and take samples and stuff. They were going to do that, and then people pointed out that, well, actually, the U.S. embargo won't allow them to do that. So they may actually have pulled out. It's not clear what their status is right now. They may or may not be part of it. Turkey, they've changed their name for anybody who hasn't caught up with that yet. They got tired of being confused with an American bird, so they decided to change. This is actually the name in Turkish. This is how the Turkish would, Turkey, yeah, something like that. But anyway, they're applying, so that it must take a while to get accepted. But they also would normally be considered a U.S. ally. One minor point is just that it's likely to be nuclear powered, the overall base, at some point. I'm sure not the first mission, but at some point. Realistically, that's going to be true for anybody, just because you need a lot of power. If you're going to start using resources on the moon, you're going to start melting regolith and that kind of stuff to get metals, or even just to get water out of it. You're going to need a lot of power, and it's going to probably be nuclear. It seems like the best option. Now, they have a whole variety of things labeled, missions 1 through 5. No doubt those will all change a lot. It's probably not worth spending much time. But there is an interesting point, though, and that's if you look at it, they're emphasizing, okay, lunar in situ research utilization technology. They're focusing on the stuff they really need to go there and stay there. So I think they're taking a much more, I would say, realistic approach toward actually being on the moon. And I'll contrast that. Now, I'm going to fall into opinion here. So this is, not everybody would agree with this. Anything on this slide you can say isn't necessarily purely factual. What I say is there's kind of two space races going on. There's one for political and economic power, and there's one for prestige. And I say the Chinese are playing both of them pretty well. We're kind of focusing on the prestige, which is kind of the old-fashioned Apollo model, where we're going to show that we're the best, by putting people on the moon, and we ultimately won that one. And then it kind of frittered away. We didn't do as much after that. China's really focusing more on, they do both, but they're kind of focusing on finding and exploiting resources, looking at what it's going to take to do the human habitation, and what they call strategic needs. And all this involves things like building materials, agriculture. They're focusing on doing a lot of this stuff. And then at some point, if fusion energy becomes a thing, helium-3 is going to be heavily involved in that. That'll all be worth a very, very lot of money. A lot of Chinese have been interested in that. It remains to be seen whether that's actually going to pay off. But anyway, it's been a big thing. On the strategic needs thing, the space program, you can read publications like the South China Morning Post or whatever it is. They interview these people in the space program, and they're pretty blatant about it. They just say the moon, or even the points along the way, like the L1 point between the two, which is strategic, that's just like the South China Sea. They want to occupy it, first, to make sure that nobody else can keep them out of it. Second, so they can actually tell people that they don't want anybody else coming into it. So they pretty much said that pretty blatantly. They're not really keeping that much of a secret. But we're not paying that much attention to it. But anyway, so that's an issue. Now, NASA actually does look at all these things, the in situ resource utilization, how do you mine the moon, all that kind of thing. They are funding these studies, but it's not a major NASA goal or even a national goal, really, when you get down to it. Most of the funding is going for planetary science and astronomy kind of things, the space telescopes and, the probes to go to Jupiter and those sort of things. And those are all good science and everything. But the rest of the funding then is going to what's called the Moon to Mars program, which includes the SLS rocket. If you sum that up, I think it's a fair summary to say that its purpose is first to do some short moon visits, and by short meaning like 5-day stays, a couple of times. And that's practice for going to Mars, where they're going to go and stay for a couple of weeks and then come back. That's that's what's built into play. You look at all the Moon to Mars plans, that's pretty much what's there. So, I mean, that's come under a lot of criticism. There's a guy, Rick Tomlinson, who actually has characterized that as what we're doing are planning camping trips. And I think he's right. But that's just opinion. Not everybody would necessarily agree with it. But it's something to consider. Some in the military have worried, the U.S. military have worried about this. And that's why you see some rather bizarre things going on, like DARPA, the Defense Advanced Research Projects Agency. I mentioned them back in, I think, October or November. We did a little thing on. They are coming up with research to figure out everything that's needed for lunar infrastructure to really actually start building a civilization on the moon. The fact that they're doing it rather than NASA is kind of telling. I mean, it basically says the military is worried that the civilians aren't doing their job, and so they're going to help out. So that shows you kind of how bad things really are when it's necessary for the military to come up with things that are clearly really should be civilian kind of concerns. So updates on other lunar missions. We've talked about these in the past, but there have been updates. So like the Japanese had the Slim lunar lander. That's the one that landed upside down. Let's see, you can see it kind of in that computer-generated image there. The question is, none of these have radioisotope sources of heat to last through the lunar night. It's 14 Earth days worth of cold temperature. They can't do it unless you have some kind of a heater. Most of those Chinese ones had that, and so they could survive the night. And they've been going for a long time. Most of these newer ones don't. It turns out, actually, the U.S. doesn't have that much of these radioisotopes. It's been kind of a problem. It's hard to get it. And so most missions, they just don't bother. But they were here, but they were just trying to demonstrate landing. So anyway, they managed to survive us the first lunar night, barely. They managed to show some operation, but some of the stuff had started to fail. They survived the second lunar night, but even more of it failed. And so I was saying the last time, it's kind of like a zombie kind of a situation where, yeah, they're there, they're kind of half dead, half alive. This time, the battery parts of the battery cells have degraded, and some of the temperature sensors stopped working. So it's on its way downhill. It probably won't last another night, or if it does, it'll be in even worse shape. But anyway, it's impressive that it survived at all because it wasn't designed to survive the night.
How cold does it get at night?
Minus 260 or I forget what it's very cold, whatever it is. I don't remember. Yeah. And then actually it gets pretty hot during the day. I mean, when you have the full sun, they had problems with overheating. They had to actually shut it down for a while because it was overheating. So it's a problem. Not having an atmosphere is just tough. So now another one that's on the moon is the Intuitive Machines one. That's the Houston company. They had the probe called Odysseus. They had entered a standby mode back in the end of February, and there was some hope that maybe they would wake back up. But they have the same problem. Without having the radioisotope heater, they just really can't survive the night. They didn't survive it at all. So that's over. They were the ones that landed. They were at kind of a 30-degree angle. As the guy showed during the press conference, they landed on a piece of blue plastic. Go figure. Okay, pop quiz. Who can guess the rocket in this country? I know. Let somebody else take it. Okay, somebody besides you two. Okay,
Yeah.
actually, there's several telltales here, and I'll tell you why in a minute. This will really mark the end of an era. This was the last of the Delta IV heavy rockets. Now, Delta IV had a long history. Delta in general had a long history. It was originally started by McDonnell Douglas, which got bought by Boeing, which then got transferred to the joint venture called United Launch Alliance, which involved Lockheed Martin. Anyway, and that was in 2006. The first flight was back in 2004. It was actually a partial failure. It made it to orbit, but it wasn't the right orbit. It wasn't far enough up. But ever since then, it's been fully successful. Its main purpose, and actually almost its own customers, have been basically big spy satellites going up the geosynchronous orbit. It takes a lot of power to get up those big, heavy satellites to get them up there. And that's what it did. I think 14 of they had 16 flights total, counting this one. 14 of those were spy satellites. One of them was the Parker Solar Probe, and there was another testing out an Orion capsule, which is ironic because the Orion capsule is meant for taking humans, but that ship is not human rated. So they just needed a ship, and so they used it for that. But anyway, most of it has basically been used by the National Reconnaissance Office, including its last mission, which was in this last month. And that is the last of all the Delta rockets, not just the Delta Heavy. It was the 45th of the Delta IVs and the 389th with the Delta name. Now, obviously, all these things, it's kind of like the Soyuz stuff from Russia. They've evolved over time, but the name, anyway, goes back to 389 launches. At the time, now we're saying here operational launch vehicle, among operational launch vehicles, it was the third highest capacity. Now, Starship doesn't count yet as operational, so it's not in this list. Right now, among rockets that have proven they can actually get to orbit or beyond and stay, NASA's SLS rocket and the SpaceX Falcon Heavy are ahead of it, but this was the next one. They can take to low Earth orbit about 63,000 pounds, which put us slightly ahead of China's Long March 5, which was their heaviest rocket. Propellants are liquid hydrogen and oxygen. For this one, unlike the Delta IV medium, which used solid rocket boosters, which is kind of interesting. It's very unusual to see that kind of a mix, to have two different kinds of boosters, but they did that. It was never human rated. Now, why is that? I'm not actually sure why. I think mainly just because they didn't need it to launch spy satellites, so the market wasn't there. But there was an interesting thing, and I think one reason some people here probably knew right away what that was is you look at those charts, you look at the black stuff that's on the rocket there. I highlighted that with the arrows. That's because you essentially get a giant fireball when this thing takes off. Apparently, it's very, very impressive to watch one of these launches. They're hydrogen engines, and they run them very hydrogen rich to begin with. And what they do is when they first start them up, they just pass a bunch of hydrogen in, essentially to purge out any other stuff. And they don't even want oxygen there because it might react with things. So they pass in a lot of hydrogen. And the hydrogen comes out the bottom. It's, where the rockets are. The hydrogen is very light, so it comes up right along the side of the rocket. So then when they finally light it up, it just explodes in this huge fireball. And they design it so that it can handle that. Obviously the paint gets charred, but it's not enough to do any real damage. So that was all actually part of the plan. So no more of these really satisfying and exciting fireballs will be available. Yeah, they're impressive. Yeah, everybody loved this rocket just for that reason, because the takeoffs were so impressive. It's been replaced by the Vulcan Centaur. That was really designed to replace that and the Atlas, which was also run by United Launch Alliance. What's interesting is the launch pad may actually end up getting used for Starship launches. Apparently, that's not determined yet. Okay, can you guess this country and rocket? This one might not be so easy. I don't think you can see any language on there. Okay, this is Russian, the Angara 5. Now that's an interesting one because they've been testing this rocket for 10 years now. This is the 4th test, and this one succeeded. The others have failed, but it's taken them. They've had their problems with budgets and everything else, so they haven't managed to do it. It's a heavy lift vehicle, meaning it can take about 54,000 pounds to low Earth orbit, essentially competing with the Vulcan. But they managed to get the cost way down. Their previous rockets were a lot more expensive. Apparently, it's about $100 million for one flight. Now this, like other new ones I've talked about recently, is only expendable. It's a disposable rocket. So again, it's also competing with the Falcon 9 of the 2010 era, rather than the Falcon 9 of 2015 when they started reusing their boosters, which allowed them to get their costs down quite a bit. So there's not much of a commercial future for them, but they definitely want to stay in the rocket business. So this is their new one. Yeah. Yes. Well, yeah, it's kerosene. Yeah, kerosene and liquid oxygen. And that's true for stage 1 and stage 2. So in that sense, they're a lot like a Falcon 9. It just took them another 10 years to actually get it working. Let's see. Anyway, yeah, I was just making the point that that's the 4th test over 10 years. One thing that happened after the last failure, actually the boosters and everything were working fine. It was the 2nd stage that was in trouble. So they have a brand new stage called Orion for the upper stage. They also have a new cosmodrome, a new launch site. They previously were launching from Kazakhstan, and they decided that they thought that was kind of risky. They're not even sure about Kazakhstan as an ally. So they decided they really better have another base of their own. So they're launching this one from a brand new site in Russia. It's actually in Russia. It's a new one. I forget. I didn't write the name down. It starts with a V, I think. I don't remember the name. But it's not the Baikonur one or whatever that. I think that was the one in Kazakhstan. Yeah. So. Over near the Polish border. Oh. Okay. Yeah. So they were anyway. They were nervous enough about it. They wanted to make sure that they could control it fully. So. Is that the Krunashev or Kruna somebody or other? Yeah, I don't know how you pronounce it, but it's something like that. Yeah.
It used to be the upper stage guys was a Ukrainian company.
Yeah.
Apparently.
Yeah.
Not getting those stages anymore.
No. Well, yeah, they bombed the factory that was making them, among other minor political problems. Yes. Yeah. I mean, yeah. Okay. So one thing we have been doing every meeting is say, how many launches have we had since our last meeting, which was March 9th, so it's about a month. And that does not include the Starship Flight Test 3, because it didn't really go into full orbit. It reached that area, but it wasn't really trying to go all the way around the Earth, so that one doesn't count. So any guesses?
17.
Okay, you're way low. Go ahead.
36.
No, you're high. Okay, so it's in between those two. All right, enough of that. The right answer is 28. So, and I listed them up here. I'll mention a few things about a few of them here. A lot of them, of course, are just Starlink launches. They're going up all the time. They have over 5,000 satellites up there. And
it was pretty close to 36. Might be worthy of BJ's gift card.
Well, that's true. All right. So you're going to say 1 million, right? Oh no, you already. All right, you're relatively close. This is a gift card for a coffee shop, which you shouldn't be drinking. But it's a $5 gift card.
I think Peter is also pretty close too, so maybe you should get a gift
card. Okay, we'll give Peter one. Yeah, I actually forgot about these things, and Nathan is reminding me that. Now, normally close doesn't count that much, but it's pretty hard to guess an exact number. Partially because you don't know which ones I even knew about and which ones I didn't. Hello, yeah. Okay, so there were a couple things I'll highlight here. There's a new rocket called Kairos, which I'd never even heard of. That's out of Japan. This was their first flight. It failed, but they're emphasizing the quick response thing, which that's been a big thing with the U.S. military lately, is to make sure that, if satellites get shot down in some kind of a conflict, you can quickly get something back up there. And they were doing the same kind of a thing. Japan was concerned about that too. The next one is a Chinese one, the Long March 2C. They were launching some lunar satellites, apparently, into what's called a distant retrograde orbit. There were communications and navigations. This was not part of their published plan, the lunar exploration program. And they really have been kind of mum. They admitted that whatever it was didn't go right. It was a partial failure because they got a launch, but they didn't go anywhere near the moon. They're stuck in low Earth orbit somewhere. But nobody really knows much about what this was. They didn't, and it wasn't really part of their official plan. So we just don't know. One of the Starlink launches, the one on March 18th, kind of in the middle of the picture here. This one, normally you typically see either 22 or 23 satellites going up for the Starlink launches. But this one included a couple Star Shield launches. Now what they are is it's the same thing, except that there's their military satellites. And whether they own them or whether I think they're probably just paying for them, and maybe they have some additional capabilities. There've only been a few of these launched before, so this is sort of one of their programs, but they are definitely getting involved in military applications now. I mentioned the Kuei-Chao communications satellite. That was one that just went up. Let's see, what else I highlighted here? Yeah. Of course, there was some crew going to the International Space Station. That's still going on. That was launched out of Russia with an American and a person from Belarus and a person from Russia. Despite everything else going on, we're still managing to kind of keep the peace up there. Let's see, a variety of mostly communication satellites, military satellites, and whatnot. Oh, okay. The April 6th launch of, the April 6th launch of Starlink. This one is only 21 of the normal satellites, but 6 of those, they're a little bigger, and the reason is they have the direct-to-cell capability. We talked about that in one of the earlier meetings, where they're competing with a couple of other companies, but basically they're really trying to set up having communications satellites. They have huge antennas to make up for the fact that they're way up in the atmosphere, but direct to your cell. And they're starting off the original plan on all of these is start off just with text messaging. But then over time, they're hoping actually so you can even talk. And the market for these is basically not so much competing with the terrestrial-based stuff because it is more expensive, but for filling in gaps. You've got regions like national parks, or even in the U.S., there's plenty of places that don't actually have cell coverage, and this is going to allow that. And so they actually work with the phone companies on these. But these are the first 6 satellites beyond the initial test ones. They put up a couple test ones earlier. They're getting more serious. They got recent permission in the last month or two to expand the locations for the tests. Actually, I think Houston is one of the spots they can test. Let's see. Okay. The April 7th Falcon 9 launch, that also introduced something new. Falcon 9 has actually kind of squashed an awful lot of other competitors, in particular in the market for small launches, like the Electron from Rocket Labs and those kind of things. They're surviving, but they're not getting a huge business because what they do is they just package up a whole lot of small satellites into one big launch, and then they spread them out, and there's little space tugs that take them around to different orbits and so on. But those were all to sun-synchronous orbits. That is, they're almost polar. They're going around in polar orbit, going over the north and south poles. For people who want different inclinations, meaning like 45 degrees compared to the equator, they're now offering that as a rideshare too. And they're called the old one transporter missions, and these are called bandwagon. They just made up names. But anyway, they're doing that. That was the first of that launch. And of course, they mentioned the last Delta flight, the Russian flight. I'll say the last Starlink flight is also interesting in one thing, and that's that for the first time they reused a booster 20 times. So that's pretty impressive. They've got quite a few that were in the teens now, but it's amazing. They're sending up so many launches. They're probably going to do 150 or so, and they only need a couple of boosters to do this. They really are turning into the airplane model where you don't have to throw away the airplane after every trip, and that's why they can keep their costs so low. Yeah.
My understanding is that this 296th launch of Falcon 9, that mission, both mission. So they're basically like this week or next week, you're gonna break the 300 flight mark for Falcon 9, which is considered a real achievement in the rocket.
Yep. So they've changed the whole model. You know, they've changed everything. And the Starship. So that you figure Falcon 9 actually basically has reduced costs from the era of the space shuttle by a factor of at least 10. I mean, so it may be even 20 depending on the time period you pick. I mean, that's huge. And I mean, for instance, you think about, you know, like the semiconductor revolution. Well, every couple of years, you know, you doubled your power, you cut the size. We're not on a curve as dramatic as that, but you know, a factor of 10, that enables a whole lot more applications. And Starship is another factor of 10 at least. I mean, maybe it'll be 100, you know, who knows? But you can probably count on at least 10. And it's not just economies of scale, it's the fact that you're reusing the second stage as well as the first stage. And having having a lot of reuse. You know, obviously if you launched once a year, it wouldn't make any difference. But if you're going to launch hundreds of times a year, it makes a huge difference. And so they're making it possible for us to get to space. And, you know, it's a necessary condition. You got to have cheap access to space if we're going to ever get there in a meaningful way. It isn't enough. You also need life support. You need, you know, how do you do agriculture on the moon? You know, how do you mine on the moon so you can use some of the, you know, the dirt to build your bricks or build factories or whatever you're going to do. All that can follow, but none of that is even worth thinking about until you have a launch capability, and that's what Starlink or you know, that's what they've accomplished on the Falcon 9 and now coming up Starship. Okay, that ends my talk. Any other comments or questions? Yeah.
Yeah, the one thing that Elon Musk has done is he's really moved the goalpost for industry.
Yeah.
So, you know, it's not just reusability, which everyone laughed at. Oh, you're going to reuse a rocket? Like, that's impossible. I don't know. Now he's doing it. And then it's like, you're going to reuse it 10 times? Well, that's just,
yeah.
You know, that's not going to work. Now he's done it. And now 20 times, it's just like, he's every 2 years or so, he's moving the goalposts for everyone else.
Yeah.
And,
well, and then reusing the second stage, which also, of course, everybody said, well, that'll be impossible because it's already up there so high. It takes a lot more fuel to get it to come back down to Earth. Well, they're working on it.
Very reasonable people in business who carefully explained in monographs and reports why it was impossible.
Yeah.
Why it was possible, but economically not worthwhile.
Yeah.
And now it's like, eh.
Well, and part of that's from having better control over the vehicle. So, for instance, both the first and the second stages in Starship, they're not really using, I mean, other than the initial turns, they're not relying on the engines firing to slow them down that much. They're just relying on the atmosphere slowing them down. And even starting from way high, you know, they have to get down somewhat. But once you get anywhere close to an atmosphere, they're letting the heating tiles take over. And they're doing a much better job of that than anyone did before. So they literally just kind of coast down until it's almost time to turn the rocket engines back on, you know, flip over and then land. And that's very different even from, say, moon landings, which typically, you know, you turn on your engines and you keep them on the entire time, all the way from being in lunar orbit all the way down to the ground.
Regarding reusability, though, the notion is that the competitors who have decided to take up the reusability problem, again, they're not being sufficiently aggressive along this axis. I think it seems that the Orion capsule, Lockheed, or what's the other one, the Starlight,
Starliner?
Starliner module. Their big thing is, you know, like, it's going to be reusable. How many times? 3 times.
Yeah.
It's like,
well, and it's a lot of work. And part of it's also how long does it take to turn it around? The space shuttle was reusable too, but it cost as much money to refurbish it as it did to build a new one. Probably, you know, it took forever. And whereas all this stuff has been designed to be just much simpler and to hold up. That's why they're using stainless steel. It can take a lot more heat. You know, it doesn't matter if it gets so hot. You know, it doesn't melt. So, yeah.
Right, we have a question online.
Yes.
Regarding the Starship fuel transfer. For fuel transfer operations, is there an accumulator type bladder that gets pressurized to move the fuel?
Okay, that wasn't.
Is there an accumulator type bladder that gets pressurized?
I don't think so. I don't actually know. You know, it was less of, okay, during takeoff, it's less of an issue with the hot staging. They never have a problem where there's a period of no gravity. Now, but for restarting, that's why they usually would plan on using the header tank to get them started. And how they do that, I'm not sure. That might just be pressure. A lot of them is just pressurized with helium. They're trying to minimize helium, trying to keep that out of the system.
A lot of hydraulic systems, like in the oil field business, use that type of accumulator bladder system. But it's basically a flexible membrane but the problem is that they have not been able to develop a flexible membrane that stays flexible at cryogenic temperature.
Yeah.
Last time I checked.
And that is minus 260, at least atmospheric pressure.
The only other way to do it is with a solid metal piston with basically like rubber seals. And once again, circumferential rubber seals. And the whole piston moves down to apply pressure to the liquid side. And once again, those seals, they haven't found any that really work at cryogenic temperature reliably. You might get it to work maybe once, but after that, it's not going to work.
Yeah.
It's just a real problem.
That may be one of the reasons, actually, they put these header tanks way up in the very, very front of the ship so that you have a long line of just pipe where, if you can probably at least keep that free of vapor. Anyway, okay, I think it's time to, okay, now we're going to learn how, oh, go ahead, one more.
Like, as you guys were mentioning, he's pushing the goalposts. And this, it's not just him, but it's a team type effort where he's having to utilize other engineers and whatnot. I met somebody the other day that was a financial analyst, investigative financial analyst for the FBI. They require a mandatory retirement after being there for 9 years. And she said that the reason why they do that is the mind is not designed to be this. Yes, for X amount of years. Is he going through engineers real fast?
I can answer that question.
Okay.
Yes, he is. A former coworker of mine worked in the oil field industry, went to work out there at Hawthorne, and he loved the job, and it was very exciting, and he was working on the valves for the human capsule, and he loved the job, but he worked basically 12 to 16 hours a day and pretty much 7 days a week. And it was hundreds and hundreds of true believers, and they were all out there on the shop floor behind their desks smiling, working away. The whole time.
It's kind of the Silicon Valley approach, it's pretty much high pressure, long hours, you give it your all, and then maybe you burn out, maybe you don't, but but it looks good on your resume, even if you burn out. Everybody knows that, okay, at least you participated in that, and that's worth something.
And the word's got around. It's like you worked for that company for a while, for like any length of time, and you could stand up to that. You could stand up to anything.
Yeah.
And it was like working for NASA in the 1960s. There were hundreds and hundreds or thousands of engineers who basically was like, "What did you do?" During that time, well, I worked on the moon rocket. Well, what else did you? Well, actually, I missed most of the 1960s. I was checked out. I was busy working. But he's got certainly a staff of hundreds and hundreds of engineers in Hawthorne, California. He's got another couple hundred working there at the facility. Where's the facility here in Texas?
Boca Chica, McGregor.
Yeah, Boca Chica, but there's the engine test facility
in McGregor, Texas.
McGregor, Texas.
Awesome.
There's pictures online of. There's one bunch.
Can you hear me okay?
Up there at the engine test facility.
And then
there's like 80 women all in this one picture, and they're all rocket engine engineers. And it's pretty cool. And there's a whole bunch of connected with retrieving the boosters from out in the ocean. There's another crew. One of the crews is all female there. So he's doing gender balance, whatever. So equal opportunity, and it's like if you do the work, you get hired. You only put up with the hours and conditions. Great, come on. And he's always advertising for new engineers because it's a strenuous environment.
Well, I know that was a lot of content to absorb. It's a lot of things to learn. So I think we should all take a moment to stand up and,
sit down.
maybe reach for the stars, Everybody's reach for the stars. Yes, maybe wave at your neighbor or something, get those arms involved. And now we can all sit back down. But did everybody sign up for the drawing? We're going to have a drawing for liftoff. Oh, you didn't sign up? Oh, well, here you go. Everybody is eligible. So liftoff is about the early days of, there you go. And I got some more pins. Oh, right there in the corner. Oh, and there's some bunch of pins right there, and I'll take these over here. And everybody can sign up. Anybody, did y'all sign up? Did he sign up too? He did. He could just write his name on a piece of paper, and I'll get you a pen. Excellent. There you go. Yeah. And then we just need to get them all inside of here. And so I just leave this right here on the corner. So we're going to have liftoff. Elon Musk and the desperate early days that launched SpaceX, so how it started, and then a SpaceX Starship model. This is how it's going. So, that meme that they have. So that's that.
The flaps are movable.
The flaps move, yes. And it's right there on the corner. Oh, and you could just put in that the disguised yogurt container. But Elon, on April 4th, had a big meeting at SpaceX down there in McGregor, Texas, and he walked through sort of making life multi-planetary and everything that they did. And you can watch a recording of his talk on Twitter, now called x.com. And it's really kind of interesting talk, but I want to give a summary of some of the things that he covered, and then also toss in my own little take on things. And I also included some of the feedback from his presentation. So this was one of the responses to Twitter. So to infinity and beyond. Okay, so becoming multi-planetary. So I want to cover the what, because a lot of people have some questions about what does it actually mean to be multi-planetary, the why, the how, and also that other how, like how will you pay for it, the when, and then the me or the you. I'm always confused about whether I should say you or me, but anyway, that works. But with that, let's talk about what multi-planetary means. Okay, Earth is currently the only place we know that humans exist. And I think that's a pretty safe bet so far with what we know. I feel comfortable saying that. We're currently a lame one-planet civilization. And what we want to do is become a really cool multi-planetary civilization. And that means creating multiple sort of self-sufficient civilizations around the solar system. And it's not about abandoning Earth. Some people talk about we're going to mess up this planet and we need to find someplace better. I guarantee you, there is nothing that we could do to this planet that would make it worse than every other place in the solar system. The rest of the solar system is really awful. Hostile. It's like, it's not even nice. Even if we had like the worst nuclear war, everybody burnt all the oil and everything, I think Earth would still be better than every other place. It's also, so we're not going to Mars because we're afraid of messing up with Earth. We're going to Mars because it's the next sort of natural step of human exploration. So it's really Earth plus all these places. And ultimately, these places will enrich the Earth, not necessarily at first in the monetary sense, but in the sense that whenever you take smart people, you put them in a challenging environment, they come with good ideas, and those good ideas could be transplanted back to Earth. You also have the drama, those stories about humanity, humans going against all odds and stuff like this, new culture, new ways of approaching life. I think it could be kind of really neat. So with that, why? So this was an interesting response that somebody had to Elon Musk's talk. So die on that rock. I don't want that. But die on that rock. No, that's the way to do it. One thing is Mars is very cold. I mean, it is so cold. Even the Minnesotans are scared of Mars. I mean, if you look, these the top numbers are in Celsius, and the bottom are in Fahrenheit. So most of it is, and then these are the maximum temperatures at the top, and then like the lower temperatures at the bottom. I mean, these are scarily cold temperatures. I mean, they do not make sweaters for this. There was a blistering hot moment in July where it got up to 68 degrees Fahrenheit. So that was like the high point. At that point, you could probably maybe go from like 12 layers to like 11. But anyway, Mars is hard. It's cold, it's dry, it's far. It'd be lonely at first. It's dangerous. But ultimately, necessity is the mother of invention. So we're going to have people on Mars figuring out problems, and their solutions can come back here to Earth. Now, there is also this feedback to Elon's talk. What you haven't considered is if you send 1 million of the best and brightest people to Mars, because Elon thinks we need a city of 1 million to be self-sufficient, so that's the number they toss it around. And they're not coming back to Earth. That's 1 million fewer smart people on Earth to do the things to keep it going. Which, I mean, it's hard to argue with that. You take 1 million people from here, you move them over there, and you don't have those 1 million people here. But you also kind of, well, I mean, like out of 8 billion people, yeah.
Yeah, drop in the bucket.
Drop in the bucket.
And don't forget the work from home whole thing.
Oh, exactly. They can work from
if you're writing
Mars.
software, and you don't have to do it real time,
Yeah.
you can transmit it back, and actually working from home would work from Mars.
Exactly.
Or the moon.
It just 40-minute round trip, 20 minutes to get there and 20 minutes back. But it could work, batch mode.
Yeah.
But anyway, so back to why. Why go to Mars? So, I think ultimately people create our own purpose. Like, okay, an example. So you really can't see too much of it, but this is a desert. It's dry. There is no vegetation that you can see, no water. I think this is just, sand right there.
There's Phoenix in the corner.
Yeah. Close. Wrong state, though. Wrong state, but that's the direction I'm going with this, right? I mean, this is not like a place to go to, but, Las Vegas is like right there, and people fly to Vegas from all over the world, but it's literally in the middle of the desert. Like, you would not go and say, I want to go to the desert and spend time, but, you put a few million people there and they do stuff, I mean, it's geographically not far from each other. I mean, I understand there's like a natural spring, and then the railroad came through here, and there's Hoover Dam over here someplace. So I mean, there's some reasons why.
Straight north, is there another important place, or is it that black outlying place there that is sort of famous?
It's not. If it is famous, I don't know about it. But it just happens to be the spot that I took the picture of from the previous thing. So it's like a random. So it's like, let's go to a city in the desert, move out a few kilometers, take a picture of that and show it to people and say, would you live there? And they go, no, I wouldn't live there. And then show them, well, it's right next to Las Vegas. But I mean, Mars, right? It's kind of like that first picture. But then, that I could visit, so that's sort of what I think is that, we can create our own purpose. So people create purpose. And once you have a purpose of going, that drives a lot. Like first, the Starship going back and forth to Mars. And Elon and SpaceX talks about coming back. So you're not stuck on Mars. These are not one-way trips. A lot of people will go and stay there, but it's not about stranding people on Mars. But once you have a reason to go back and forth, you start building other craft. There's a reason to build other craft, and these craft keep getting bigger and more like their own self-contained cities. And ultimately, this allows for us to go any place in the solar system, even generation ships to other stars. Yes.
And it is worth noting that Mars is red for a reason. It has a whole lot of particular element that it actually is used on all those things that
Iron.
It's used in all those photographs. So this is not pie in the sky. This is real stuff.
Now, if you talk to an accountant and you say there's a reason why Mars is red, they would agree with you too.
Oh, yeah.
uh, but we'll get to that later. So, so how? Well, anyway, so this is kind of the goal. We want a fully self-sustaining city on Mars, which basically means about 1 million people to cover all the skills that we need. And you probably need to deliver a few million tons of materials. Now, you have a couple of limitations to be aware of. One is, there's only every 26 months, Mars and Earth kind of align. And so that means, you need to send enough stuff to kind of last for, a few years whenever you have the opportunity. Now, I should also point out, we talked about Starlink a little bit. Now, Starlink, you could get access to internet and it has like a little router, you log onto your computer. This is a little weight thing that they have on the Starlink router to kind of remind people that by buying Starlink, you're actually funding us going to Mars, which I think is kind of cool. So, just to tell you about scale, 10 launches per day, 200 plus tons to low Earth orbit per launch. This comes out to be 1.5 million tons to LEO per 26 months, of which nets out to like 250K actually to the surface of Mars. And the loss between that 1.5 and that 250 is fuel to actually get there. Those are huge numbers, by the way. But
Per day.
Yeah.
Within that launch window.
10. Well, I think what you would do is do 10 launches every single day. You would stage all of your stuff in orbit, and then in that 26 windows, you would send thousands of ships at one point. Battlestar Galactica, except without the Cylons, is sort of the image, So,
Ragtag fleet.
I mean, it's probably all going to look very similar to each other. Everybody's in starships and stuff, but maybe they have like little ships that go between the ships as they go. So you're like, man, I can't really stand the view on this ship. I'm going to go over to that ship. So maybe that'd be really good from a psychological standpoint. Okay, this is a human for scale. Basically, a human is a pixel, a little dot. And then this is the Falcon 1. That is what this book is about. That is how SpaceX got started. The first 3 flights were a failure. Originally, whenever they thought they could start, they were going to start SpaceX. Elon's like only have enough for 3 flights, and so after that 3rd flight, it looked really chancy that they were able to continue. But they were able to get enough money together for a 4th flight. It was successful. Then they got a contract from NASA to deliver cargo to the International Space Station, and then that allowed for SpaceX to develop the Falcon 9. You have 2 versions here. You have one with like the Dragon capsule on top that's used to deliver supplies and people to the International Space Station. In that case, the capsule at the very top and also the first stage is reusable. And then you have this other version. Instead of having a capsule at the top, it has satellites inside of this payload fairing, but they've also made it so that they actually reuse the payload fairings. They come back. And so the only part that's not reused is the second stage that's right here in the middle, and then also the trunk of the Dragon. So reuse is key. Then the Falcon Heavy, which is just a variant of that, and then Starship, which is what we've been talking about today. And if you're excited about it, you're going to enjoy the rest of this talk, because we're going to talk about some more. But mass to orbit. Oh, yes.
That Starship is bigger than the Apollo moon rocket.
Absolutely.
And that's worth remembering. I mean, he's going to try and catch an Apollo moon rocket when it comes back. I mean, that's just a phenomenally staggering notion. And the fact that they're even trying to bring them back, reuse them, is just almost unimaginable.
And that's another thing I should point out, is this Starship is 100% reusable, and this cost about the same as a 747 to build, and is the most powerful rocket, even more powerful than Apollo, but it's going to be cheaper per flight than the Falcon 1, because all they have to do is pay for the fuel. and refurbish it. So that will completely change the economics of spaceflight. So most powerful, like that Falcon 1, half a ton to orbit. So the cost of doing that, you're going to be able to do that, 200. So it's like a factor of, oh goodness, 400 times the amount of material for less cost per flight. And then, this is what the test flight 3 was. This is kind of like Starship 2, and then Starship 3, where they're going to get to that 200 times, is actually going to be longer. Let me just move on. And the key thing is the Raptor engine, which powers it. First stage has 33 of them. The second one has, I think, six. And then you can see that the progression, it's getting a lot more refined, fewer parts, fewer flanges and other stuff. A lot of this material they have on the outside, a lot of sensors. Like, whenever they're doing the development, they want to be able to know all the details and everything, right? And then you could be a little bit more selective as you refine the design. And then this is what's happening during the flight. So just like in the moon architecture, you have the Starship goes up into orbit. You have a whole bunch of flights where they do the fueling up of the Starship. And then eventually it goes over to Mars. And then they actually will create, using the carbon dioxide in the atmosphere plus hydrogen, you react it together and you're able to create methane and then fuel it up and send it back to Earth. And on the way back, since Mars' gravity is 1/3 as much as Earth, and also the atmosphere is extremely thin. I mean, so thin that if you were at the farthest point on the Earth, it would be like multiple times thicker at that point. So it's a really thin atmosphere.
But the good thing is it's still thick enough that it helps in landing. In other words, you can use aero braking, meaning just like we're doing with with Starship and everything else, you heat up a bunch of thermal tiles, and then you can use a parachute too.
Yeah.
And that the moon is much harder, actually. It's easier to land on Mars by far.
That you at least have something to break with. That's true. Any atmosphere is important. You're going to need a lot of these Starships. In fact, they're talking about manufacturing 1,000 a year, which is 3 per day. And they're building a factory down there in Boca Chica, Texas, to actually do this. They're right now, I think they're close to doing one every 6 weeks, something like that. So it's not really that far off. But they have experience building like 5,000 Starlink satellites in a year. And then, of course, from World War II, we were able to build close to 7,000 bombers in a year. So, and then, if you add Boeing and Airbus together, you're over 1,000 there. So, not impossible, big numbers, sure. But this could be the result. And then, you start out small and you kind of grow. And then, we could go there.
It looks like Las Vegas.
I know one of these places has an all-you-can-eat buffet. I'm pretty sure. Huh? Oh, you mean from Earth? Well, I mean, some people, it could also go the other way. We're like, we had Psyche, which is like that metallic asteroid, which we're talking about refining and mining. You have materials here on Mars, which you could use, but I mean, asteroids are probably, the moon might actually have some deposits of stuff that we could use. So it could be.
Well, the Regulus is like
really
30 or 40% aluminum and titanium. So you just have to have a lot of energy to melt it, basically.
If only we had a big bright thing in the sky that we could focus on.
Yes. One catch is that the reality is you're probably going to be living mostly underground because you need a lot of dirt regolith for radiation shielding. And then they never show that in these pictures.
Yeah, this is the tip of the civilization iceberg, as it were. So.
Yeah, there's a Sanskrit symbol there.
Yeah. But anyway, it's not just transportation. What we're working on is the cart, right? No, that's wrong. We're working on the horse. Yes, we're working on the horse. This is the cart. You'll have to get the cart later on. You'll need power generation, ice mining, propeller production, life support, construction, mining, a whole bunch of stuff. But okay, so now we're going to talk about the Red Mars bit. How are we going to fund this sinkhole? And there's ways to do it. I mean, first of all, you have launch. Now, SpaceX last year launched 90% of all the mass to orbit of the world, every world. China launched 6%. Everybody else put together launched 4%. And just to kind of put this in perspective, SpaceX's growth, take a look at this. This is animation of their launches only from Florida. They've also launched from Vandenberg over in California too. You see the years marching at the top, and this only goes till last year. This year they've been launching multiple times a week. There was that. I thought it was because they actually put that in, but they have 2 launch pads going. You also see some flybacks happening too. It's just kind of mind-boggling. I mean, you know, you hear SpaceX launched and you're like, yeah, sure, they're launching, but just to kind of give you an idea on the scale, you know, and this is happening, this happened. You know? I mean, that's kind of exhausting to watch, actually, but exciting too at the same time. Yeah. Yeah. So that's how they're. So what are they launching? I mean, of course, they're launching satellites for other people, but Starlink is key. I mean, you got Starlink that you can use for boats and, you know, remote areas and campers. I mean, it's just kind of amazing. And you have like the Starlink constellation. They're also launching supplies to International Space Station, people to International Space Station, and of course, you know, in 2030, anybody knows what happens to the International Space Station? Decommissioning, yes, yes, that is worthy of a PGA's gift card. Very good, very good. Okay, yes, the plan is to build a vehicle that will dock with the International Space Station, slow it down enough, and make it land in the Pacific. What's left of it, you know, most of it burning up in the atmosphere. So you may be wondering, hey, what happens to the Crew Dragon and all these other space vehicles after they get rid of the International Space Station? Anybody have thoughts on that? Oh, they're bringing it down to Earth, but what will be in the space after the space station, if anything? Axiom, yes. That's definitely worth a gift card. So. Excellent. Anyway, this is a company called VAST. They're planning to build a number of space stations, and they'll have SpaceX dock with it. This is Starlab. I wish I could tell you about the scale of this. This is essentially the same size as Skylab. It's going to launch on a Starship, and anyway, it's just like huge. But these are just 2 of several companies that are planning to build space stations. And NASA, instead of paying for their own space station, will just rent time and buy services from these other people. And then
that little thing on the cup, is that one that that company here?
NanoRacks and the Bishop airlock?
Yeah.
Sure looks like it, doesn't it?
Yeah.
Yeah, I think NanoRacks is involved with Starlab, so it wouldn't surprise me. Of course, SpaceX, as Greg mentioned, is involved in Artemis, getting to the moon, but Artemis is a camping trip. And, you know, Elon is like, well, we're going to Mars and building a place there. Let's just build a base on the moon as well. So this might be right next to the NASA landing site, you know, so if they want to come over, they can.
I could have, it's got his little, oh, I thought it was one of his trucks there, yeah.
Yeah, oh, hey, it could be. It could be a Cybertruck, like right there. And then, anyway, some more feedback from the launch from Twitter. Also, Dear Moon. How many people have heard of Dear Moon?
Oh, yeah.
Yeah, this is the billionaire in Japan who's funding a trip for 8 of these 10 people to go around the moon.
I recognize number 3 there.
Yes, Tim Dodd, the everyday astronaut, is going. So instead of becoming an astronaut, you could have started a YouTube channel and potentially made it to the moon. So anyway.
And there are different things like poets and musicians.
Poets, musicians, designers, painters. Yeah, exactly. And then anybody know who Dennis Tito is? Does that name ring a bell? Yes. Which one?
Vodka guy?
Not the vodka guy. I think he used to work Vanguard. I think he was the first low cost exchange traded or mutual fund that like followed the S&P. But he and his wife had bought the second passage on the second trip to go around the moon. But Dennis Tito actually was the first space tourist. Back in April 2001, the Russians sent him up to the International Space Station. NASA was not happy about that. In fact, originally, whenever he came with the other two cosmonauts to Houston to train for that trip, they said, we can't train you with this tourist. But eventually, at that time, Russia was more free market when it came to space than we were, because they just were so desperate for money at the time. But anyway, he made it there.
Banned from the American side of the space station, if I remember correctly.
That's right.
There was a line, you couldn't cross it.
That is true. That's true. Okay, so this is more futuristic, but there's another way that they're going to get money, kind of like at the Starlink way. This way, you can sell to people, and that is Earth-to-Earth transportation. Imagine 6:30 a.m., you're in New York, and you want to go to Shanghai. What do? Do you get on a plane, or do you get on a boat? These people are getting on a boat, just in case it wasn't coming through. But this boat takes you out to a platform which has your ride waiting for you. Like 100 people, I think, could fit on a Starship. Don't worry about the in-flight food. You won't be there long enough. Yeah. Takes off, and within about 30 minutes, you land at your destination. Now, you're going to go outside the atmosphere. You get some moments of free fall. Maybe you unbuckle for a few minutes, look out, do some somersaults. You put some water in the air and see it glob up, and essentially you can make it any place in the world in like 30, 40 minutes. 45 minutes maybe. And here you come and land. And land in Shanghai on the platform, and then you just fill up the flight and you can go. Now, how much do you think this is going to cost you? $10,000. Okay, anybody else? Yes. 11,000. Okay, that's a good Price is Right strategy. Just a little bit over. $20,000. $20,000. So that I think they can sell. I think people would buy that. People would say, you do that, you would do it. Now, they say that they can be profitable, going for the price of a first-class airline ticket. So and the $14,000 is a first-class airline ticket. And this is also 15 hours. So I don't know about you, saving 14 and a half hours for spending a little bit more money might be worthwhile. I think I'd be willing to forego the airport lounge in order to get there quicker. Yeah, I mean, can you imagine this? You you have a meeting in Shanghai. It's the end of the day. You fly at the end of the day. Your family goes to sleep. Whatever. You have your meeting. You come back in the morning, and it's like you never left. You're just like. Good to go.
Get up to Houston, you drive down to Galveston, get on a rocket, breakfast, get on a rocket, launch over to, say, London, and then meet some friends there and go out to lunch, go shopping in London, and then come back, and you would still hit rush hour traffic here at Houston on the way back to Galveston. That was the civilian astronaut course here in days.
Well, the other question I wanted to talk about was when. When is this happening? When? And so, we had test flight 3 in March, and they're talking about having test flight 4 in May, which is only a few weeks from now. And I think it's worth kind of just seeing some of the highlights of test flight 3. I mean, this is a rocket that's bigger than the Saturn V that took us to the moon. and this is in Texas, you know. I mean, Brownsville being like the gateway to the solar system, I'm hoping that the control center was not shaking like that. But you know, it's just like just kind of amazing. And this really happened last month. Real hardware, not PowerPoint, not animations. You know, I heard a quote one time that said, in theory, there's no difference between theory and reality, but in reality, there is. And that's why you need to build, that's why you need to build real hardware and see it work, you know? I mean, and they already have the ship built for the next flight, and the one after that, and the one after that. They've already tested the other one. And then, you know, that's the hot staging that you talked about happening right there. And then the flipping. You know, you can see the booster coming back, and then it's coming through the atmosphere, and then, you know, kind of do well and lose control of it, right? And then you have the Starship. That's this part, the Starship right there. Now, what's kind of interesting about these videos is they actually had the cameras on the flaps, which they have to move to kind of control. And so you'll see like the camera just like shoo, and then, you know, the craft is also doing its thing. So it's like, and there's the plasma right there, you know, and you can see it's on the side. That's not good, you know, because this part doesn't have the heat tiles. So, but I mean, they were able to do kind of amazing things with that flight. And next up, we already have the spacecraft. So flight test 4 will probably happen in May. They're testing the Starship right there that they're planning to use. So we already talked about that and that. So a self-sufficient civilization on Mars within 20 years. And there's a lot of people that are really excited about that. There's some people that aren't. That's fine. Let them do their thing. We'll do our thing. It's okay. So how can you help? Okay. So first of all, by 2044, 1 million humans on Mars. We can make this happen. But I think people have to know that is actually an option. And one way that we can actually let them know that is an option is to talk to them about it. And where else to talk to them about it other than a big convention? So we have a booth set up at Comicpalooza that's happening later this month. You may have noticed that on the bottom here. Maybe you were a little hesitant to check that, you know, like what are you committing to? Willing is not a commitment. It's just an indication of, you know, open to the possibilities. Yeah, you're safe if you check that. But what we're doing is we're getting a booth right here by the entrance to the exhibit hall. And there's like 40 to 50,000 people attending between May 24th and May 26th. And
I didn't realize it was that big. 40,000 to 50,000.
That's the numbers that I have read. Oh, is it? I don't know.
Anybody got one of those little intelligent computer things? Sunday.
Oh, yes, that is Sunday. I do mean that. Yes, very good.
Sunday.
You too get a gift card. There you go. She tells me she never gets to win anything at these. Anyway, this is a smart move, trust me. But yeah, we're really going to do this, and we need your help. So I have a little form, bit.ly help North Houston space with Comicpalooza. Or you could just scan this QR code. I wonder if it actually works though. Maybe, does it? Yeah, it does. Okay, and that'll take you to a Google form. Yes, Google form. It does work. I definitely recommend testing it out. But we need all sorts of help. We need people to provide ideas on what we could do at the booth. I got a fairly lengthy email of some ideas that we're sorting through. So even if you want to help on other ideas, we got ideas. Help getting ready before the events. We need help with setup, which is actually Thursday, the day before the event starts. We need people just to stand there and talk to people 2 to 4 hours, and help with tear down. Follow up after the event. We'll probably have lots of contact information. And also if you have things that we could exhibit, pictures, models, posters, books, and things to give away. And if you have stuff, that's great. If you have ideas for things, that's good. If you want to help us get stuff, that's good. And unfortunately, we do need monetary help too, because we have to buy our own passes. We'll buy like maybe 3 or 4 passes. We got a special place. And then, if you're just going and you don't want to do anything, just coming by and saying hi would be cool too. And then if you plan to drive, even if you're just one of the hi people, maybe you could bring some people with you who don't have transportation. So anyway, need your help. So who wants to help? Kids are like, yay! All these people. See, that's supposed to be encouraging. We're like, we mirror what we see. So this is yeah, I want to do it. Okay. Let's get down to business here. Okay. First of all, we have everybody submitted one of these. I'm just going to take a little moment and fold them up a little bit more so that they're a little easier to shuffle. And Greg, how about I'll let you maybe select. Actually, I have even a better idea. Okay.
Give us a hand. All these all fold.
Oh yeah, you could fold some too. Okay. Okay. Yeah. Okay, and so I'm going to shake it up. And if you would do me the honor of selecting the winner. Okay, who? Peter? Training? Excellent. Well, congratulations, Peter. Now you can't say that anymore. Now, Peter, you do have a choice. Would you like the book or the model?
I'm going to take the model and give it to my further graduate.
Okay.
All right.
Okay. Now, all of y'all, we still have the book. We still have the book. So, Peter, since you won that one, why don't you choose who gets the book?
My name back in?
I did not.
Well, I said on here then.
Okay. Oh, yeah. Darius, you're going to read about the Elon Musk and the desperate early days that launched SpaceX. So we will talk about this after you get done with it. Thank you. Okay, cool. That's awesome. Okay, next. Okay. There's the QR code if you need it again. But I invite y'all, if you want, to just hang out. Some of y'all have PJ coffee gift cards, and you're like, when am I going to use that? In about 10 minutes, actually. Because you could just drive the 2 minutes down here to PJ's Coffee, and we could just sit there and talk and figure out what we're going to do about this Comic Palooza thing, or just hang out and just chit chat. So I definitely welcome all of y'all. And what I would like to do is go ahead and get the people online to turn on their cameras. So if the people online could turn on your cameras, and then we can take just a real quick group picture. There's got to be a way to do this. Oh, do I have to unspotlight? I have used this program before. Just want to point that out. Let's see. Remove spotlight. Okay, cool. That's brilliant. Okay, and we could just get everybody maybe to come over here and take just a real quick picture. It's kind of, I just think it's kind of cool. And maybe I can grab somebody. Hello. Would you mind taking a picture for me? Just wanted to take a real quick group picture and just, thank you.
It should be like this, right? It should be like this.
Okay.
Yeah.
Do you need us to squeeze together? Sonia.
But you turn a little bit sideways. Shoulder, yeah.
Thank you so much. I really appreciate it.
I apologize if it's not good enough.
Oh, no, it's wonderful. And anyway, so thank you all online. And can I get you a picture of you as your model?
Yeah.
Excellent. And I think we had a book winner. Where's our book winner?
Oh, yeah.
Well, anyway, that's pretty much the end of our meeting. So thank you all for coming. Feel free to take some stickers. Feel free to take we got some patches, Ad Astra. And thank you all very much. Yep, and we'll just go ahead and hang up the call. And thank you all. Thank you. Thank you for coming.
I don't have much time
Go over 2 years and start
for
talking
this
about
PJ meeting.
today.
Yeah.
Okay.
And have you thought about